This video is an introduction to our work published in ECCV 2024 titled Unified Embedding Alignment for Open Vocabulary Video Instance Segmentation. Open Vocabulary Video Instance Segmentation is an emerging vision task that aims to simultaneously classify, track, and segment arbitrary objects from an open set of categories and videos. Compared to VS, Open Vocabulary VS is much more challenging since it requires handling novel categories that have never appeared in the training set. While these existing Open Vocabulary VS solutions have shown significant promise, the following questions naturally arise. 1. Achieving alignment between text and video in clip-based models, and 2. Considering temporal consistency. Firstly, the Open Vocabulary method based on clip directly obtains the classification score of each instance by calculating the similarity between query embedding and text embedding. Due to the inconsistent training sample sources between VLM and VS models, there is a huge domain gap between these two models, which is not conducive to text and video alignment. How to alleviate the domain gap has become the key to solving this problem. Secondly, the model training and inference in current methods are conducted on the image level rather than the video level, which did not fully utilize rich spatiotemporal context in video. Thus, the classification and segmentation results are not temporal consistent for the same instance across frames. Tackling these two issues can provide insights into Open Vocabulary Video Instance Segmentation model design and motivate us to propose a novel, elegant framework from Unified Embedding Alignment View, OV-Former. OV-Former seamlessly incorporates large pre-trained VLM and VS model within an efficient video-level training regimen. Our proposed OV-Former consists of 3 modules. Instance Query Generation module generates video-level instance queries that represent the entire clip. Instead of calculating instance queries for each frame independently as image-level training or generating mass proposals explicitly, we use a set of video-level instance queries to represent the entire video clip, which further excavates spatiotemporal information and enhances temporal consistency of the instances. Then, Open Vocabulary Classification module performs unified embedding alignment between the instance queries and the image features of clip to generate feature-aligned class embeddings, then classify them with the text embeddings computed from a clip text encoder. We employ the cross-attention mechanism to reconcile the cross-model correlation between the VS and VLM for unified embedding alignment. This simple and lightweight operation remedies the domain gap between query embeddings and clip text embeddings to facilitate open vocabulary classification. Finally, Instance Segmentation and Association module generates and tracks the instances through bipartite matching. We employ semi-online inference scheme, which uses video clip as input and performs clip-level instance tracking with the Hungarian algorithm during testing. The regime not only better utilizes multi-frame information compared to online method, but also makes it possible for our models to conduct long video inference compared to offline setting. The table reports the performance comparison between OV-Former and some baseline models on LVVS validation set, including OV2Seg and some proposed reduced association baseline models. OV-Former with ResNet 50 backbone achieves 21.9 map, 22.1 MAPB, and 21.8 MAPN, outperforming the leading method OV2Seg by a large margin with 7.7, 4.9, and 9.9, respectively. Also, the performance of OV-Former with SwinB backbone further improves, reaching 24.7 map, 26.8 MAPB, and 23.1 MAPN. To further evaluate the zero-shot generalization ability of our model, we directly test OV-Former on 3 closed vocabulary VS datasets without fine-tuning the model using the training sample on the corresponding dataset. Results in table show that OV-Former achieves a stronger base-to-new generalization on both U2VS 2019 and 2021 benchmarks. Notably, for the more challenging OVS benchmark, all compared methods suffer from performance degradation due to the long-term videos and serious object occlusions. In spite of the presence of complex scenes, our method still delivers a solid overtaking trend. Figure provides some representative qualitative results of ours against OV2Seg on the LVVS set. OV-Former not only correctly classifies instances, but also provides clearer details for small parts.